Okay, so today in review day 2, we're going to talk about all the geometric and statistics topics that you need to know. A lot of things that we went over prepare you for the SAT and the ACT. So there's going to be some things you're going to be like, but we did more than that. Yep, we did a lot more than what you actually need for your state exam. So just focus on this video and the practice that comes with it for your final exam. And the first thing is vertical angles. Hopefully you remember what vertical angles are. Vertical angles are created when two lines cross each other, and 1 and 2 would be vertical angles. Okay, the definition is that they are angles that are created when opposite rays intersect. The great thing about them is angle 1 is congruent to angle 2. So if angle 1 was 50, so would angle 2. Next, we talked about parallel lines and all the wonderful little angles that they create. So first, lines being parallel have to have these arrows, otherwise you cannot assume that they are parallel. These lines, when they're cut by transversal, create 8 different angles. You need to be able to identify those 8 angles and their relationships. So remember, we have alternate exterior, which would be like angle 1 and 8. Alternate interior, which would be like angle 3 and 6. Consecutive interior, which would be like 3 and 5. And corresponding, which would be angle 1 and angle 5. In these cases, alternate exterior, alternate interior, and corresponding are all congruent. Consecutive interior are supplementary or add up to be 180. You should also know angle 1 and angle 2 are a linear pair, meaning they form a line, and are also 180 degrees or supplementary. Then there's a perpendicular bisector. When you hear that word, you should think of 2 things. There are 2 words there, 2 things to think about. Perpendicular bisector. Perpendicular means 90 degrees. Bisector cuts in half. So if I have a line and this is a perpendicular bisector, that's a 90-degree angle, and those 2 segment pieces are equal to each other. The wonderful thing about this is if I were to draw a line to the endpoints, these are also equal to each other. Next, we talked about triangles and a lot of things dealing with triangles. But again, there's only a few things that you should remember from your triangles. 1, angles add up to be 180. That you should know from a long, long time ago. The next thing you should remember is what type of triangle I just drew. It is an isosceles triangle, and with isosceles triangles, 2 sides are congruent, so angle A is also congruent to angle C. Base angles will be congruent. You should know what this line segment is called, DE. DE is the mid segment, and its wonderful relationship is that DE is parallel to AC, and DE's measurement is 1/2 of AC. In this unit, we actually talked about a lot of different segments. We talked about altitudes and angle bisectors and perpendicular bisectors and medians. And then there's centers, if you remember orthocenter and all those wonderful centers and their relationships. The great thing about your final exam is the only one that you are required to know is your centroid theorem. And centroid theorem is all about your medians. And remember, medians are the segments in the middle. They come from a vertex and they go to the midpoint. It looks like this. So let that be A, B. And then we'll do another one. Call that CD. And then from this to this midpoint, call that EF, making G is the centroid. Hopefully you remember the relationship between these segments, and that is the fact that AG is 2/3 of AB, or CG is 2/3 of CD, and lastly, EG is 2/3 of EF. And remember, we kind of looked at this as like parts to the whole. If this was 2/3, then this piece is 1/3, making up the whole thing. So you can go back and forth between problems with that. There may be variables, there may just be numbers involved. So let's add in some numbers. What if I told you this piece was 4, this piece was 8, and then we'll say AB is 15. I won't mark the whole thing. And I want to know what Z and W are. So I want to know what the variables are here. So this is 8, 4, W, X, Y, Z, AB being 15. So first off, if I look at my W and my Z, I have this picture here of A, G, B, Z, W, and AB is 15. What I know is this is 2/3 of the whole thing, and this would be 1/3. So if I broke 15 down into 3 parts, because it's in thirds, that would be 5. So this piece has to be 10, and this piece has to be 5, because 2/3 of 15 is 10, and 1/3 is 5. Then looking at my next variable, let's just look at X. I have E, G, F. I know this is X and this is 4. This piece is 1/3 the whole thing because EG is 2/3. That just means that X has to be 8 because 2/3 is twice as big as 1/3. Lastly, in CGD, we have 8 here and we have Y here. This is just the reverse. This is 2/3, that's 1/3. So that means this has to be 4 because it is twice as big. If you have any questions on this, please ask Miss Lewis. She's great at explaining the centroid theorem and using this technique. The last thing about triangles that you need to remember are your special right triangles, and we've had lots of practice over that the last few weeks. Remember, you have a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, your sides or your legs are congruent. Your hypotenuse is your leg times the square root of 2, and you should be comfortable going back and forth between all of them. In a 30, 60, 90 triangle, your short leg is across from 30. It's represented by X. Your long leg across from 60 is your short times the square root of 3. Your hypotenuse is always twice as short. And again, you should be able to go back and forth between any side given. Next, we talked about quadrilaterals. If you remember, we talked about parallelograms, squares, rhombus, trapezoid, all of those. Fortunately, all you need to know are 2 of them for your state test. One being a parallelogram, because it's kind of like the parent of everything. And then the other is a rectangle, which hopefully you know lots about. Remember, with a parallelogram, opposite sides are parallel and congruent. That's definition. We also know that opposite angles are congruent. And diagonals bisect each other. So remember, that word bisect means cut in half. A rectangle has all parallelogram properties because it is by definition a parallelogram. And it has a couple extra things. You know it has 4 right angles by definition. That's what makes it stand out. And because those angles are right and the opposite sides are congruent, when we talk about the diagonals, we actually have congruent triangles, meaning our diagonals are actually going to be congruent to each other. And you will use these properties to solve problems on your final exam. Next, we talked about everyone's favorite topic, circles. With circles, you learned a bunch of different topics. The great thing is you don't need to know as much about circles for your final exam as you do for the ACT. Circles are all over your ACT and SAT, as you probably have seen. The number one thing that you need to remember is the equation of a circle and how to pull off pieces and describe it using completing the square to put it in standard form, all those techniques. So remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center of our circle is hk, and r represents our radius. You may be simply asked, what's the center? How big's the radius? How big's the diameter? Anything about an equation you should know. Then there were some properties about circles that we talked about, and these are the ones that you must know for your state exam. They're specifically listed as standards. First off, if you have a circle and you have this little segment here, we'll say circle A, this is BC. If you remember, BC we call tangent because it touches only once. And the wonderful thing about a tangent line is if it touches a radius or a diameter, because a radius is part of a diameter, then it creates this wonderful little right angle. So angle B is 90. If it connects with a radius. If it connects with a chord, it doesn't mean anything. It has to connect with that center of the circle. Then we talked about different types of angles in a circle. So we'll let this be ABC, and we'll draw another angle down here, and we'll put that point as D. If you remember, angle ABC is called a central angle, and that is because the vertex is in the center of the circle. Angle ADC is inscribed because it is inside the circle. Then you need to remember your relationships. If I told you AB was 70, ABC is 70, that would mean that arc AC is also 70 because central angles equal their arcs. However, an inscribed angle would be 35. The inscribed angle is 1/2 the arc, or the arc is twice as big as the inscribed angle. With inscribed angles, we have a special case when I have something that's inscribed, but one of the sides is the diameter. This forms a semicircle here, and we all know a semicircle is 180 degrees. So by our rule for inscribed angles, that means this angle has to be 90 degrees, making this triangle a right triangle. It is not necessarily a special right triangle, but it is a 90-degree angle, making it a triangle. So these two angles would add up to be 90, and you could technically use the Pythagorean theorem to find any side length if you were asked to do so.